Okay, this will be our last one, and I started it so at least to save us a little bit of time. So we're going to find the Maclaurin polynomial, which implies we're centered at 0. That means the same thing. I would not have to include it. For cosine of x, we're going to find the first 4 non-zero terms. Okay, so I set it up. I did cosine, took the derivatives. You notice I did a bunch of them because something happens here. Because at 0, when you go evaluate, the first time you get 1, sine of 0, you get 0. So I said non-zero. Okay, so there would be my first 4, my first 3, I mean. That would be my fourth one. Okay, so now if we were to write this, I would say f of x is approximately equal to, and since that is the sixth derivative, it becomes the P6 of n because, or the P6 because it took 6 derivatives to get our fourth non-zero. Okay, so it's going to be 1, and then this one is minus 1, and that, since it is the second derivative, it's x squared over 2 factorial. Okay, this is going to be plus 1x to the fourth over 4 factorial, and then our last one would be negative 1x to the sixth. Okay, I just don't want to mess up my signs there. Over 6 factorial. Okay? All right. So that is our Maclaurin, which means centered at 0, for non-zero. It didn't say a P sub 4, it said for non-zero. So you got to be comfortable with those, with that description. Okay, your last one is to approximate at 0.1. Well, I luckily did this ahead of time. So I'm going to say f of x, or f of 0.1, is approximately equal to P6 of 0.1, which is 1 minus 0.1 squared over 2 factorial plus 0.1 to the fourth over 4 factorial. Yes, you have to show the substitution. Negative 1 times 0.1 to the sixth over 6 factorial. And if I compute that out, and I did it on my 89 here already, I get 1 point... No, it's not the right one. Is that the right one? No, it's not the right one. So I don't have the value for that one. Sorry about that. I did it for the next problem. Okay, so I will go ahead and get that one for you. I will post it in the notes. The one on the next page, or the last page, is the one that I actually have the values computed for. Okay? All right. Which, by the way, this is a little bit less than 1. Okay? All right. I think I did that one. No. Okay. All right. So our next one on our last page here is we are going to find the Maclaurin, fourth degree Maclaurin for e to the x and use it to approximate 0.2. So fourth degree means I'm going to take 4 derivatives. So I'm going to do f of x is e to the x. Well, the nice thing is about this one is each derivative is same. All right, so I need to do one more. Okay, and since it's Maclaurin, that's when C is 0. So if you want to go ahead and just compute this, each of those values is just going to be 1. Okay, so this is our first one. So we're going to say f of x is approximately equal to P4 of x, which is 1 plus 1x centered at 0 over 1 factorial plus 1x squared over 2 factorial plus 1x cubed over 3 factorial plus 1x to the fourth over 4 factorial. And that would be our P4 Maclaurin. Okay. So if I want to approximate e to the 0.2, that is, so e to the 0.2 is approximately equal, you can say f of x is approximately equal to P4 of 0.2 of 1 plus 0.2 over 1 plus 0.2 squared over 2 plus 0.2 cubed over 6 plus 0.2 cubed over 24. And if you work that out, you get 1.2214. Okay, I will tell you the e to the 0.2, if you type it in the calculator, you get a value of 1.22140275816. That is the calculator value. So if you look at that, we're correct to 4 digits. Okay? And we're actually correct to 5 digits, possibly. Well, 4 digits. Okay. All right, so the last one we're going to do is, I gave you coefficients again, so you don't have to go compute them, but it's a 4th degree centered at x equals 3. Okay? All right. So if I go ahead and do that, oh, I do have that one for the cosine. Let's go back. Let's go back. This is 0.995004165278, which, by the way, the calculator value for cosine of 0.1 is identical. So it's correct out to that point. Now, the further you go out from 0, if you go to 0.2, that would not be exact. Okay, or it would not be as close. I'm sorry. All right. So let's go ahead and write this one. So it's a 4th degree Taylor centered at 3. If it just says Maclaurin, we don't have to tell you where it's centered. Okay, if it's Taylor, we got to say where it's centered. So we're going to say f of x is approximately equal to p4 of x, which is 3 minus 2 times x minus 3 plus 4 times x minus 3 squared over 2 factorial, and then it's plus 1 times x minus 3 cubed over 3 factorial, and then it's minus 5 times x minus 3 to the 4th over 4 factorial. Okay, so that's our Taylor. Now we're going to go approximate it at 3.2. So f of 3.2 is approximately equal to P4 of 3.2. Now when I go plug in 3.2 up here, does everybody agree that's just going to be 0.2 once I plug it in? Okay, because we are really approximating 0.2 units away from the center. So I get 3 minus 2 times 0.2 plus 4 times 0.2 squared over 2 factorial plus 1 times 0.2 cubed over 3 factorial minus 5 times 0.2 to the 4th over 4 factorial. Okay, and again on the notes I'll have that value for you. I did it for the cosine, should have done that in order, but I didn't. Okay, so we approximated 3.2 by just plugging it in, and it works out that all those are 0.2. All right, the last one is now we're going to integrate f. So we're going to integrate this function between 0 and t, which if you think about it, if I plug in 0 for each of these, I'm still going to get a value. So a little bit different. Okay, so g of t is equal to the integral from 0 to t, and I'm going to write out each of those. So it's 3 minus 2 times x minus 3 plus, I'm going to simplify, let's leave it as 4 over 2 factorial times x minus 3 squared. Let's leave each of those as x minus 3 cubed over 3 factorial minus 5 times x minus 3 to the 4th over 4 factorial. Okay, and that would be dx. So if I integrate that, I'm going to get 3x minus 2 times x minus 3 squared, and I'm going to get a 2 on the bottom. Okay, here I'm going to get plus 4 times x minus 3 cubed, but that 2 factorial now becomes a 3 factorial. This is plus x minus 3 to the 4th. When I divide by 4 here, that's going to make that a 4 factorial. And then it's minus 4 times x minus 3 to the 5th over 5 factorial. We still need to go evaluate between 0 and t. Okay? All right. So if I go plug in t, it's just going to be the same but with t. But when I plug in 0, I'm going to get value. I'm going to get a number. Okay? So I get 3t. We'll answer this one down here. So I get 3t minus 2 times t minus 3 squared over 2 factorial plus 4 over 3 factorial times t minus 3 cubed plus x or t minus 3 to the 4th over 4 factorial minus 5 times t minus 3 to the 5th over 5 factorial. Minus, okay, when I plug in 0 here, I get 0. When I plug in 0 here, that's 9 times negative 1. So it's minus 9. Okay, when I plug in 0 here, I get 27, negative 27, divided by, so I'm going to write, it's just going to be minus 4 times, no, plus 4 times negative 27 over 6. So we don't need it, we're not going to simplify that today. Plus, well, negative 3 cubed is 81 over 4 factorial. If I plug in 0 there, I believe that's negative, it's minus 5 times negative 243 over, okay, this was 24. And if I multiply, it's 120. Okay, so we do have a constant this time because it wasn't from 3 to t. Doesn't happen often, but I at least want to do one of those so you didn't blow through that when you plug in the bottom value that you get a 0. Okay, and the last one is, what is the center of this one? Well, the center is still at t equals 3, or it's at t is 3, because when you integrate, the center does not what? Does not change. The last thing I want to say is this. The only place that this is exact is at 3. That's why it was not, you won't get 3. The only place you will get the exact value is at the center. Okay, the only place you'll get the exact value here would be at the center, which is at 3. The only place you get an exact value here is at the center, which is 3. Does not change when we integrate. Okay? All right, folks. Have a great day. Thank you for your time. Bye-bye.